Hi everyone, so this is Bella here again. Today I'm taking you through some deep learning machine learning models that you can use to detect fake news. And this is in completion of the DIT 650 at the City University of Seattle. So there's the agenda, introduction, techniques, conclusion, and references. The problem statement today is basically around fake news. So fake news detection is modeled as a binary classification problem. Basically, the objective is to classify news articles into two categories, fake and true or genuine. The approach involves processing data to build a classifier and then predicting um, if a news article is fake or genuine based on that. The project workflow here includes importing the data. So we're going to be loading data as a data frame, pre-processing the data like we did last time. Then we'll perform some feature engineering, and then we'll do some exploratory data analysis, and then build and validate the classification model. So here are some of the steps that we use. First, we obviously imported our libraries, and then we imported two data sets, one called fake.csv and then the other called true.csv. The data set was gotten from a cable. Afterwards, we added a new column called label, and we identified the fake data, information from the fake data as 1, while information from the true data is 0. And then we concatenated the two data set together, and we called it diff. So below there is a sample of the data set when we read the first 5 records. The next step here is to do some data analysis. What's the count of our data by data types? As you can see, we have politics news, world news, left news, government news, US news, and Middle Eastern news. I'm trying to understand our data some more. We then wanted to get a little bit understanding of the length of each text data, which is the news itself. And then we run some code there to get the length in a new column called length. We also then checked for what's the minimum length and the maximum length of the text news. Minimum being 1 and maximum being 51,794. Looking further here, the bar chart on the right shows you the count or the articles for the different types of news. And at the bottom here, it shows you the count of the articles for both true, where the news is true as well as when it's fake. Yeah. This next slide here, still in terms of exploring our data, shows you the data count for each of the records, for each of the news type. So government news, Middle Eastern news, news, politics. So you see the Middle Eastern news, US news, left side, left side news, politics, are probably one of the type of news with the most count of words. So next we're going to data preprocessing, and here we convert the text to lowercase, remove punctuation and stop words, correct spelling errors, lematize the words to get the root words. And here are some of the tools that we used. So here is what we did here. The first one here converts to lowercase, and we explained why to kind of keep all the data as same. The next text here removes punctuation marks. If you look at that, it replaces a punctuation mark with a space. And the next step here removes stop words. So those are like stop words in English, so that's the, this, in, and things like that. And the last step here, what it does is it does some lemmatization of the words, whereby it kind of brings the words down to its root to kind of explain this. So once we did the data pre-processing, the next is feature extraction. So basically, previous machine learning models that I've created were basically very binary kind of words, like is this churn or not would be an example. Is this person likely to churn or not? From like say a network or something like that. In this case, it has to do this particular data set has to do with a lot of words that needs to be put in binary terms so that your machine learning model can use them. And that is where feature extraction comes in. So this feature extraction basically takes the words and put them in numbers. For this particular video, the feature extraction technique that we used was TF-IDF. But as you can see, there's so many others. So there's word embedding, so there's word to vec, and BRT and the likes. So more to come on that. So here is what we did there with our data. We first split the data. So we split the data and we got like our X values and our Y values. And then we trained the data and we tested the data. And afterwards, we did our feature engineering right below. And that gave us our binary. So with that, what we then did was we created a general model for the data. And once we created that, we then ran the models using different classification methods such as naïve Bayes, logistic regression, random forest, and SVM. And the purpose of this was to find which of these models would work best in this category of data. And what we found was logistic regression and random forest were one of the better models. So once we found that out, next what we did was we fit the model. So we fit the model with two kinds of classifiers. One was the logistic regression and the second was the random forest classifier. After fitting the model, we ran the predictions using the test data now, not the trained data, and we evaluated our model. So if you look right here, when we evaluated the model, we got a precision of 0.99, which is pretty high, and the AUC of 0.99%. That's on the left side for logistic regression. And on the right side for random forest classifier, we got a precision of 100% that is, for the model. I will question why we got such a high precision. I will want to look into the model better to see if there's some overfitting or underfitting. But for this class, this is where we would stop and we'll pick it up again next time. So in terms of the machine learning models we used or that were tested, here are the four that I mentioned, and some of the better performing ones were random forest and logistic regression. So next here is the references that we used and an opportunity for question and answers. Thank you very much. Bye.